Let's talk about the limit definition of the derivative, specifically the derivative at a specific number. So we're going to be using this definition at the top of the screen here. So f prime of some number equals the limit of this slope formula. So when we're doing a problem, we'll be given a function formula like you see here, and then they'll ask for f prime of 1, f prime of whatever number. So we're going to put this number into this definition as the a. So right here, here, and here. And the x's stay actual x's. And what we're going to build when we do that is a limit of the type 0 over 0. So this is the kind where if you try to plug in the number that x is approaching, you get 0 on top and bottom. And we know from a previous section that we have like 3 major strategies for a 0 over 0 limit. So if what you're looking at is polynomials, we're going to factor those polynomials and cancel. And as soon as we cancel top and bottom, whatever's holding us back, we can plug in our number and be done. If what we're looking at has some kind of square root in it, we're going to do the conjugate trick. And if what we're looking at has fractions, we'll do the LCD. All right, so in this video, I actually have one of each. So my first example will have polynomials. This second example will have the root. And the third example will have the fraction. All right, so let's start with this first example, f prime of 1. I'm going to start by just writing this definition, but with 1 filled in for a. So that'll be the limit as x approaches 1. F of x minus f of 1 over x minus 1. All right, so we have 2 things to fill in our numerator. F of x is going to be the entire f of x formula, so all this goes right there. And then f of 1 is going to be a number, so I just need to compute that by plugging in 1 to this formula. And I get negative 2. 3 minus 5 is negative 2. Okay, so if I plug things in, I'll have the limit as x approaches 1. So f of x is now 3x squared minus 5x, that whole formula. And then we're going to subtract the value of f of 1, which is negative 2. So in the next step, I'm actually going to write this as a plus 2, or I could just do it now. And all of that is over x minus 1 from before. So if we try to plug in 1, on the bottom, of course, we get 0, and on the top, we get 3 minus 5 plus 2, which is also 0. So we say, okay, it's a 0 over 0 limit, and what I'm looking at is polynomials. So I need to factor and cancel. So I need to factor 3x squared minus 5x plus 2. And because of that coefficient of 3, I'm going to do factor by grouping. Why don't I do some scratch work off to the side here? So I'll have 3x squared minus 5x plus 2. All right, so let's remember factor by grouping. I need to multiply 3 times 2, and I get 6. So I'm looking for 2 numbers that multiply to 6 and add to negative 5. That looks like I could do minus 2 minus 3. Those will multiply to 6 and add to negative 5. So the 3x squared and the plus 2 stay the same. And that minus 3 minus 2 that I decided, I'm going to use them to split up the minus 5x. So I'll do minus 3x minus 2x, or I could put those in the other order. It all shakes out the same. And now I'm going to take my 4 terms in 2 groups, factor out what I can, and I'm shooting to have the same thing in each set of parentheses. So with 3x squared minus 3x, I can pull out a 3x, and I get x minus 1. Between negative 2x and positive 2, I'm going to pull out a negative 2. So that in the parentheses, I have x minus 1 instead of negative x plus 1. And now these parentheses match. So the factored form has x minus 1, the one that they both have in common. And then I'll steal the front pieces, 3x minus 2, to make the other part. Like that. Okay, so this is the factored form of that polynomial. So I'm going to use it and come back over here. So I have limit as x approaches 1 of this x minus 1, 3x minus 2 over x minus 1. And now I can cancel x minus 1, x minus 1. And now I'm free to just plug in the 1 for x, and I get 3 minus 2 is 1. So in this case, for this function, f prime of 1 equals 1. All right, let's try another one. Now we have a root function, and it's asking for f prime of 6. So again, I'm going to start by just writing down this definition with a 6 in the 3 spots for a. So I'll have the limit as x approaches 6, f of x minus f of 6 over x minus 6. And just like before, the two parts of the numerator we are responsible for filling in. So f of x will be the original f of x formula. This guy goes right here. And then for f of 6, we just need to compute what number that is. So we'll plug 6 in for x in our function. And we get 3. Okay, so that gives us the limit as x approaches 6 of root x plus 3, minus 3, not 6, minus the 3 from f of 6, and then over x minus 6. So again, because x is approaching a number, we might try to just plug the number in to see. And once again, we have 0 over 0. So we consult the flow chart up here. It's 0 over 0, and I have a square root. So I'm going to do the conjugate trick in this example. So I want to multiply and divide by the conjugate of the square root part. So that's going to be square root plus 3, top and bottom. So this is the conjugate of that because I'm switching the subtraction between the terms to addition. Okay, so in the numerator, I'm going to have, this is a minus b times a plus b. So it'll come out to a squared minus b squared. And then on the bottom, nothing magical happens. It's just going to stay exactly how we see it here. So x minus 6 times root x plus 3. Okay, so in the top here, this square root and this square cancels. This is just regular x plus 3, and then minus this 9. X plus 3 minus 9 will be x minus 6. X plus 3 from here, and then minus the 9 from the 3 squared. And now we kind of see the path forward because there's an x minus 6 on the top and the bottom. So they can cancel. When there's nothing left, there's a 1. And now we can just plug in a 6 for our x value, and there's nothing holding us back. This is root 9, which is 3. So my answer here is 1/6 overall. So f prime of 6 in this case is 1/6. All right, let's do one more. We've kind of covered 2 of the possibilities. We've done a polynomial, a root function, and now we'll do a fraction function, which is also known as a rational function. So now we have 1 over x minus 4 for the function, and we're asked for f prime of 7. So again, I'll start with the limit definition of the derivative with a 7 filled in for the a. And then now I need to fill in the 2 parts of the numerator. Regular f of x just gets filled in with the function formula itself. F of 7, I need to compute. I'm just going to plug in 7 for x right here. And I get 1/3. Okay, so let's see what that gives us. Limit as x approaches 7, 1 over x minus 4 minus 1/3 over x minus 7. And again, if I try to plug in 7 for x, I get 0 over 0. Because I see fractions, I'm going to do an LCD. So I'm going to ignore the x minus 7 down here for a minute and just focus on these fractions up top. 1 over x minus 4 minus 1/3. I want to make them have a common denominator so I can combine them into a single fraction. So this fraction needs times 3 top and bottom. This one needs x minus 4 top and bottom. And what that gives me Oh, there we go. All right, so we have 3 times x minus 4 as the common denominator. And across the top, I have 3 minus 1 times x minus 4. So in the next step, I'm going to distribute this minus 1 into those parentheses. I also have this x minus 7, so I could write all of this over x minus 7, or I can write it off on the side as 1 over x minus 7. So divided by x minus 7 is the same as times 1 over x minus 7. All right, so if I distribute this subtraction, I get 3 minus x plus 4. Over 3 times x minus 4, and I still have my 1 over x minus 7 just sitting on the outside. 3 plus 4 is 7. And we have this familiar situation that we've run into a handful of times. We know we want x minus 7's top and bottom to cancel so that we can plug in 7. This x minus 7 is in perfect shape, ready to go. This 7 minus x is kind of backwards. So we are going to pull out a minus 1. That gives me minus 7 plus x. And then I can just reorder that to x minus 7. That gives me negative 1 x minus 7 over 3 times x minus 4. Everything else the same. Now these guys can cancel. And I can finally just plug in 7 for x. And that's negative 1 over 3 times 3 is 9. So negative 1/9 is my answer.